Okay, in the previous lessons, we modified our program so that the motor stays turned on continually using a latch instruction. Then we added a stop push button so that the motor can be shut down. And after that, we learned why we should use a normally closed stop switch when we want to turn the motor off. So in this lesson, we are going to refine the program further by learning how and why we need to use a feedback contact. You already know that when the start switch is pressed, the PLC program will cause a 24-volt DC signal to be sent to the contactor coil. The coil will be energized, the contactor contacts will be closed, and as a result, the motor will be turned on. Now, when we press the start switch, the program shows that the output is true, the contactor has worked as expected, and now the motor is turned on. However, if this contactor is broken and is not functioning properly, in reality its contacts have not been closed, and so the motor is not turned on. In fact, using this program as it stands now, we could have a situation where the operator sitting in the control room sees on the monitoring system that the motor is turned on, while in reality, the contactor has not worked and the motor is turned off. Okay, so what can we do to prevent this from happening? This is when a single feedback contact can save us a lot of time and headaches. So how can we implement this in our program? As you may know, this contactor has a few other open and closed contacts, in addition to these 3 open contacts that we've already used. So what we can do is make a 24-volt connection from the power supply to one of the contactor's open contacts, and then connect the other side of the contact to one of the DI module inputs. By doing this, when the PLC energizes the contactor coil, if the contactor is working properly, this open contact will be closed, and so a 24-volt signal will be sent to the PLC input, making that input true. This is known as a feedback contact. Its function is to let us know that everything is working properly and that the motor is also turned on. We also need to make a small change to our program so that we can benefit from the advantage of this feedback contact. We just need to change the address of this latch instruction from Q40 to IO2, which is the address of the channel that the feedback contact is physically connected to. Now, let's test the program to see if it works properly. When we press the start switch, the PLC output sends an electrical signal to the contactor coil as before, which causes these 3 contacts here to be closed, allowing the power to reach the motor. This open contact will also be closed at the same time, making IO2 true and showing us that the contactor has worked fine. Now, when we stop pressing the start switch, because the feedback input has been used as a latch instruction here, the motor continues to be energized. So this is our first scenario where the contactor is working properly. Now, let's see what happens in the second scenario where the contactor is broken. Now, if we press the start switch, you can see that the Q40 output is going to be true. But since the contactor is not working now, these contacts won't close, the motor won't be energized, and on top of that, the feedback contact won't be closed. So now, as soon as we take our hand off the switch, the output is going to be false. So that's how we can check whether our contactor is working or not using a simple feedback contact.